So it's time to explain the problems for LeetCode Biweekly Contest 27. I didn't do so well in this contest, mostly because I didn't solve problem 4, but now I think I know how to do it. So, problem 1. Making two arrays equal by reversing subarrays. Given two integer arrays of equal length, target, and array, in one step you can select any non-empty subarray of array and reverse it. You're allowed to make any number of steps and return true if you can make array equal to target or false otherwise. So basically, first thing is if the numbers in the target array are not equal to the numbers in the original array, then we can't do any swaps to make them equal because there's always going to be some number missing. But otherwise, if the numbers are the same, we can always perform a number of operations to make them equal because the bubble sorting algorithm allows you to take consecutive pairs in the array and then reverse them. And after doing this any number of times, then you eventually get it sorted. And yeah, this means we can make the array into any order we want. So we just have to know that the original array contains the same numbers as the target array. Problem 2. Check if a string contains all binary codes of size k. You're given a binary string and an integer s. Return true if any binary code of length k is a substring of s. Otherwise, return false. So how we solve this problem is we look at all substrings of length k, and for all those substrings we add it to a hash set. At the end we look if the hash set is the correct size, and by the correct size I mean there's going to be 2 to the k possible binary codes of size k, so we need to make sure that the hash set has size 2 to the k, and that is exactly what we do here. And adding the strings should take linear time. Problem 3. Course schedule 4. There are a total of n courses you have to take, labeled from 0 to n-1. Some courses may have direct prerequisites. For example, you may have to take course 1 before you take course 0, which is expressed as a pair 1, 0. It is expressed in a pair prerequisite course that it is a prerequisite of. Given the total number of courses n, a list of direct prerequisite pairs and a list of queries pairs, return an array which is true or false for each query pair. The query pair is ij, where you should return true if I is a prerequisite of j. Yeah, so if A is a prerequisite of B and B is a prerequisite of C, then A is a prerequisite of C. So how we do this is we basically construct an adjacency table, and this means for every course we list out all the courses that it is a prerequisite of. Once we construct that shouldn't take too much time because n is at most 100 and the prerequisite list is like at most n squared, right? So this shouldn't take too much time. And then we do a DFS for the queries. So we're given ij as the query. We want to do a DFS starting at j to see if I appears in the prerequisite like flood fill. So basically we just do a DFS on the graph to see if I is contained in the subgraph of j, and if so, then we can return true. Problem 4, cherry pickup 2. You're given a rows times columns matrix grid representing a field of cherries. Each cell in grid represents the number of cherries that you can collect. You have 2 robots that can collect cherries for you. Robot 1 is located in the top left corner 0, 0, and robot 2 is located in the top right corner. Return the maximum number of cherries collection using both robots by following the rules below. From a cell ij, robots can move to any of the 3 cells below it. When a robot is passing through the cell, it picks up all the cherries and the cell becomes an empty cell. When both robots stay on the same cell, only one of them can take the cherries. Both robots cannot move outside of the grid, and both robots should reach the end. You can actually just straight bash this, but the thing is, we use recursion, and when you use recursion, you can always, most of the time, you can make it better by using a DP table. And the thing is, in Python, you can actually use this thing called LRU cache, which basically is the DP table. So you can just put that in front of the recursion function, and that just caches the function results for you. And that's pretty good because then you don't have to actually implement your own DP system. But it's not that hard to do anyway. So basically, the recursion accepts a row and then the locations of the 2 robots in that row, and it returns the maximum number of cherries you can collect by moving downwards. And yeah, we just consider all 9 possibilities because there's 3 possibilities for each robot. And using dynamic programming, this can reduce the time complexity. Yeah, so it's just a straight bash with dynamic programming. So it's basically dynamic programming. Alright, overall this contest was not so great for me because I didn't solve problem 6, and I got memory limit exceeded on problem 5 because I tried to do something not so optimal, and like it used up a lot of memory. So yeah, I'll be doing the weekly contest later today at 7:30, and tomorrow I'll do Code Forces. Yeah. Great, so thanks for watching. If you have any feedback, you can leave it in the comments, and goodbye.